My name is Moses from St. Andrew's College, Kitovu, and I'm glad to take you through number 7, part A. Number 7, part A, we need to describe the translation T1. So if we look at this translation critically, we observe that it is likely to be a reflection, and we are now going to just prove whether it's a reflection and get the line of reflection. So in these matrix transformations, if we are writing these matrices, we start with the image of I and J. This one, we generate them from using the unit square. So I'm going to bring out that image on my plane, and we see. So my unit square is here. This is my I, this is my J. So, but now I have my image of I is 0, -1. This means that my x is 0 and my y is -1. It means that our image of I is there. Then this means that our x is -1 and then our y is 0. So we shall see our image of J there. So if you look at this image and you see the distance here and distance here, you see that if we project a line in the middle there, we shall clearly be able to see reflection. So let's try and see whether it can come out. If I project a line there, yes, and you know in reflection, the image distance equals to the object distance. So, and also we need to complete a perfect square. So if I complete my perfect square here, you see that it is real, and also here you see that it is actually real. So this becomes a reflection. So this line, how do we get this line? It is clearly known and seen that this line, it is clearly known and seen that this line is just, if we pick a value of a value here and we find it that, let's take our point on that, which is -1, 1. So we are seeing that our x is a negative and our y is a positive. Therefore the line is y equals to -x. So we can rearrange this and we have y plus x equals to 0. Therefore this is the equation of this line. So this line is y plus x equals to what? 0. So as we are seeing here, we have now obtained our line of reflection. So how do we now describe our transformation? We now come and say, therefore T1 is a reflection on the line. Our line is there, y plus x equals to 0. So this is how we describe it. This is how we describe that transformation T1. So 2, we can clearly observe that we can pull out a certain figure and it gives us identity matrix there. So let's pull out 2 and we see. So if we pull out 2, we shall have a 1, 0, 0, 1. And this is clearly seen by everyone that this is an identity matrix. So these 2 become the scale factor of our enlargement, and with the center as 0, 0. So from this we can just go on and describe the matrix. So the matrix of transformation T2, we can now describe it fully. So our T2 is and enlargement of, now when we put the of, we bring the scale factor of scale factor 2 with the center 0 0. Or if you don't want to say this, you can simply say T2 is an enlargement of scale factor 2 with the origin as the center of enlargement, and you're done. This is how we describe the matrix transformation T2.
Hello members. Hello. My name is Amber Felix from St. Henry's College, Kitovu, and I'm here to take you through part C and part D. For part C, we are required to find a single matrix that would map P double prime, Q double prime, R double prime back to triangle PQR. So this is what we had. We had PQR, the initial triangle, which was mapped onto P prime, Q prime, R prime by matrix T1, and P prime, Q prime was mapped onto P double prime, Q double prime, R double prime by matrix T2. So we all know that if they tell us to get a single matrix that maps PQR to P double prime, Q double prime, we get this matrix, we pre-multiply it with this matrix. But in this case, they have said we should get a matrix that will map P double prime, Q double prime, R double prime back to the original triangle. So if we get the matrix that will map P prime, PQR to P double prime, Q double prime, and R double prime, and we get its inverse, we shall be able to get the matrix that will map P double prime, Q double prime, R double prime back to the original matrix. So this is what we mean. T2, we pre-multiply it with T1. And our T2 was 2 0 0 2. And our T1 was 0 negative 1 negative 1 0. So when you're multiplying, you multiply row by column. So here we're going to have 2 times 0, which is a 0, plus 0 times negative 1, which is also a 0. So here I have 0 plus 0. Then we have 2 times negative 1, negative 1, negative 2, plus 0 times 0, which is also 0. So we have negative 2 plus 0. We have 0 times 0, which is a 0. Then 2 times negative 1 is negative 2. So I have 0 plus negative 2. Sorry. Then we multiply 0 times negative 1, which is 0. Then 2 times 0, which is also 0. So we add, here it is 0, negative 2, negative 2, and 0. So this is the matrix that will map PQR to P double prime, Q double prime, R double prime. But in the question, we are required to find the matrix that will map P double prime, Q double prime, R double prime back to the original triangle. So if we get the matrix, the inverse of this one, we shall be able to get the matrix that maps this one back to the original triangle. So we have T2, T1, and we indicate that we are finding the what? The inverse. But we all know that the inverse is equal to 1 over the determinant times the adjoint. So this is our matrix, and we have this one as the major and this one as the minor. So in getting the determinant, we shall get the major, the product of the major minus the product of the what? Of the minor. So I think we first find the determinant of this matrix. We shall have 0 times 0 minus negative 2 times negative 2. This is 0 minus negative 4. Minus 4, because we are multiplying a negative times a negative. And our determinant will be negative 4. Now, we said the inverse. This is the inverse is equal to 1 over the determinant times the adjoint. So in part B, we calculated the coordinates of what? Of this. This is our matrix that we are finding the inverse of this matrix. So we are going to change for the adjoint. We are supposed to change the digits in the major, and then we multiply negative 1 to each of the digits in the what? In the minor line. So we have 1 over negative 4, and our adjoint is 0. Here we have 2, here we have 2, and here we have 0. So when you multiply this one times this one, you get 0. Negative 4 times 2, you get negative a half. Negative a half. Then negative 4 times 2, you get negative a half. And then negative 4 times 0, we shall get 0. So this is the matrix that will map P double prime, Q double prime, R double prime back to the original triangle, which is P, Q, and R. Yes, we continue with part D, which requires us to find the coordinates of P, Q, and R. So in part C, we have found the single matrix that can map P double prime, Q double prime, and R double prime back to the original object. So if you use that single matrix and we pre-multiply it with the coordinates, the ones we have found in C of P double prime, Q double prime, and R double prime, we can be able to find the coordinates of the original triangle P, Q, and R. So we shall use row by column. And this will be our solution, like we have been doing. So we shall have 0 times 0, which is 0. Then negative a half times 2, which is negative 1. Then here I have 0 plus 0, 0 plus negative 7, then negative 5 plus 0, then 2 plus negative 0 plus negative 2, then 0 plus, and then we come to the addition. So we have 0 plus negative 1, which is negative 1, 0 plus negative 7, which is negative 7, then 0 plus negative 2, which is negative 2, 0 plus 0, we have 0, negative 5 plus 0, negative 5, then 0 plus 0, we have 0. So these are the coordinates. Actually, these will be, this is P, this is Q, and this is R. So we come and state the coordinates as, and we say P is negative 1, 0, Q is negative 7, negative 5, and R is negative 2 and 0. So we have found the coordinates of P, Q, and R.
Thank you, my brother Felix, for taking us through the numbers. Allow me once again take you through part E of number 7. Part E of number 7 wants us to get the ratio of area of triangle PQR to area of the image P double prime, Q double prime, R double prime. So from this, we know that our area scale factor is given by the determinant of T2, T1. So this time around, we have our determinant as negative 4. So what we have to know is the negative sign there shows us that the transformation involves a reflection. Therefore, we have to get the magnitude of our determinant. Therefore, we get the magnitude of the determinant T2, T1. So here, the magnitude of negative 4, which will give us area of PQ, P double prime, Q double prime, R double prime, out of area of PQR. So right now we can, because what we need should be on the left, and what we already have should be on the right. Therefore, I rearrange, bring this side, and then I take this one, the other side. Therefore, our area of P double prime, Q double prime, R double prime, out of area of PQR. Now, the magnitude becomes the positive, therefore equals to 4. So we can, any whole number is out of 1. But what is the question telling us? The question is telling us to get the ratio of area of PQR to the area of P double prime, Q double prime, and R double prime. Therefore, we have to get the reciprocal of both of them. Therefore, if I have my area of PQR out of area of P double prime, Q double prime, R double prime will be equal to a quarter. Therefore, if I'm expressing it in ratio form, this is 1 to 4. And therefore, I conclude and say, therefore, the ratio of the area of triangle PQR to area of triangle P double prime, Q double prime, R double prime is equal to 1 to 4.